In section 2, we said if you have a parallelogram, then you know this. If you have a parallelogram, then you know this. Now they're just flip-flopping it. So theorem 8.9, if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So you literally just flipped it. So the other one said if it's a parallelogram, your opposite sides are congruent. This one says if your opposite sides are congruent, it's a parallelogram. All right? If opposite angles are congruent, it's a parallelogram. If the diagonals bisect each other, it's a parallelogram, right? And then this is one that we haven't looked at. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then it's a parallelogram. So even if you don't have both sides, like both sets of sides, if you have one set that is both parallel and congruent, you can say it's a parallelogram. All right? A parallelogram. So here they say determine whether the quadrilateral is a parallelogram. Well, let's see what we have here. We have congruent angles here. We have congruent angles here. Yes, according to the theorem that we just looked at, that's a parallelogram. That's all we have to do there. All right? Let's look at the concept summary, just the test for parallelograms. Both pairs of opposite sides are parallel. Yes. Both pairs of opposite sides are congruent, then yes. Both pairs of opposite angles are congruent, then yes. Diagonals bisect each other, then yes. A pair of opposite sides is both parallel and congruent, then yes. So these are just basically the 5 things you can look for to decide if you have a parallelogram. And so a lot of times you'll be doing the same exact concept, but the question will be asked differently. So in the last section, they said, here's a parallelogram. What is X or Y? Here they're saying is, tell me what X or Y has to be in order for this to be a parallelogram. And it's really the same number crunching that you would do either way they ask it. Just you need to make sure that you understand what the question is asking. So let's give this example. Find X and Y so that the quadrilateral is a parallelogram. In last section, they would say, here's a parallelogram, find X and Y. And so they're just asking the same exact question a different way. And so for these, you would set the 4y equal to the 6y minus 42 and solve for y. You would set the 6x minus 12 equal to the 2x plus 36 and solve the x. This is the same process you would have done in section 2, right? Same thing with your angles below, or your your angles if they said it, or your diagonals below. So here they've given us diagonal information. They're telling me this little piece equals something and this little piece equals something. This little piece and this little piece. Well, to make sure those are parallelograms, I just have to make sure that those are equal. And so you're going to solve it the same way. X is equal to 5x minus 28, and 5y is equal to 2y plus 12. All right, so coordinate geometry. This is determine whether the figure with the given vertices is a parallelogram. Use the method indicated. And the first method they tell us is the slope formula. Slope, all right? So in order to just use the slope formula and prove that this is a parallelogram, then I have to somehow prove that this has the same slope as that. That would make them parallel. And that this has the same slope as that. That would also make it. So all 4 of them must be parallel to each other. So I have to have 2 sets if I am just going to use slope. All right? And so that's what you're going to do. You're going to take the first one, which is AB, and we're going to find the slope of this. So you have to remember your slope formula. Subtract your y's over subtract your x's, right? So the slope of this guy is going to be what? Negative 1/5, right? And I have to do the same thing for D to C, right? I have to do the same thing here. A to B and D to C. So if I'm going to do this one, I'm going to say subtract my y's, negative 1 minus 0, over subtract my x's, 6 minus 1. All right, so I know that those are parallel. I've proven one side, one group. Now I have to go to the other one, right? So now I have to do A to D, same thing. Y's minus your x's, all right? Y's minus your x's. So I'm going to get 3/2 for that one. And then I need to go from B to C. Y's over your x's. And so I've just proven that those are parallel as well. And so I know that this is a parallelogram because I have done 2 sides each, both of those parallel. All right, now for this one, they tell us to use the distance and the slope formula. So I don't need to do the distance for all 4 sides and the slope for all 4 sides because I have that one little extra theorem in this section that tells me what? If I have one set that is both parallel and congruent, I'm done. So I can just pick one of my sets and do it just for those. Slope formula for those, distance formula for those. I will prove the slopes are the same and I'll prove the distance, which means the length is the same. And I don't have to do it for all 4 sides. Now there's going to come a time when you're trying to prove maybe a square or something like that, and then you have to go to all 4 sides to do something like that. But if it's just a parallelogram, just one set, and that's fine. And so it doesn't matter which set you use because if one works, the other one will work. So if we just use S to P and R to Q, then we can just do it that way. So let's do the slope formula first. So if I go S and P, my slope formula. So I'm going to say 3 minus 7, y is on top, 5 minus a -2, x is on bottom. I will get -4 over +7, -4/7. And if I do the same thing for my R to Q, I'm going to say -5 minus a -1 over 1 minus a -6. Again, I will get -4/7. So I now know they're parallel. That much I know. I just need to prove that they are congruent. So jog your memory. What's the distance formula? All right. Here's the deal. I have already solved for the subtraction of my x's and the subtraction of my y's for both of these because I just did the slope formula, didn't I? Mm-hmm. Right? So if I'm going to do then the distance formula for the first one, my x's subtracted are right here and my y's subtracted are right there, right? So I can just say, well, my y subtracted, that's 7. X is subtracted is 7, plus my y subtracted, well, that's -4. Easy enough? Yeah. So I have 49 plus 16, right? Which gives me what? Square root of 65, right? And then I have the same exact thing. If the slopes were the same, subtraction of my x's, that's 7. Subtraction of my y's, that's -4. Those are the same.